I like mathematics, so I'm just going to talk to you about mathematics. A little piece, maybe you'll learn something in this. We classify triangles in two distinct ways. One by the largest angle, right, acute, or obtuse. The other by the length of the sides, isosceles, equilateral, scalene. But I want to put the two together in a different way than you probably have seen. So first of all, here's a line to AB. What I want to do is pick a point anywhere on the plane and completely describe the triangle by picking one from the first set and one from the second set. Completely mix the two. We seldom blend the two. First of all, I'd like to find all the right triangles. I bet you would agree that any point on these two lines, vertical lines through A and B, will form a right triangle. Agree? For example, the triangle PAB is a right triangle. Any one there. Are there any other places on this plane where you'll get a right triangle? I'll give you a bit to think. Sure, if we do a circle whose diameter is AB, any point on that blue circle will form a right triangle because it intercepts a half circle. The inscribed angle intercepts a semicircle. So triangle PAB is a right triangle. So right now, I claim I can pick any point anywhere on that screen and tell you exactly what kind of triangle it is. For example, P1AB is an acute. P2AB is obtuse. P3AB is obtuse. Okay? Pick any point anywhere I am in business with that category. Now I'd like to find where all the isosceles triangles are. Any idea? Certainly any point on the perpendicular bisector of AB will form an isosceles triangle. Agree? Okay, so the triangle here, PAB, is isosceles. It's also what? Acute. Okay? Are there any other places on the plane which will form an isosceles triangle? Well, I claim if you draw a circle whose radius is AB, center in A, will be a isosceles triangle because PA is equal to PB. Agree? Now, I've left all these lines on the point. I claim right now I can pick any point on this plane. P1AB is obtuse and isosceles. P2AB is equilateral and acute. Right? P3A, I'm sorry, wrong one. Isosceles thinking. I'm losing myself here. P4AB is scalene and obtuse. I can pick a point anywhere on the plane. You pick it, you can define the triangle. Tell me exactly in the two categories. I put the two ideas together. In this particular case, P7AB is scalene and obtuse. I can go anywhere, pick any point. This is fast for 5 minutes, but you play with it, it's pretty cool. Now, here's a cool point. Take that line segment CD. If I take a point and start to move across, I can describe that triangle just as it moves across. This is what the students told me to do. Let's follow it across. You can see it goes from acute to obtuse, goes through everything. You can completely describe it. Then the kids pushed the idea to me. They said, why don't we take this and spin it around the x-axis into 3 space and pick any point in space and describe the triangle. Pretty cool. Then they said, do it the other axis. Well, my point, mathematical concepts do not exist in silos. We find opportunities to push things together. This is one idea. If you play with it and think about it, you'll grow, your students grow. I'm done.